Hello everyone, and welcome back to the course. In this lecture, we're going to explore data frames. Data frames are a two-dimensional data structure and will be what you use most of the time when working with data in Pandas. Let's move on over into Jupyter Notebook and get started. The first thing we'll do is go ahead and import NumPy and Pandas with the same aliases as before. Now that we've imported our two libraries, we'll start by looking at how to create data frames. If we call the name of our function and have a look at its documentation with Shift and Tab, we can see that it's got quite a few different parameters here. To create our data frame, the first thing we'll have to do is create some data for it. So I'll go ahead and do this with the np.random.randint function that we looked at in the last section. And I'll create this variable with a low value of 1, a stop value of 101. I'll reshape this data to have 4 rows and 2 columns. And then this is what the output of our variable looks like. Then we'll go ahead and call the pd.dataframe function. And in here, as we looked at before, the first argument I will have to provide is the data, and I'll use the variable that we just created here, which I called data. So I'll go ahead and pass this in. And then next, we can provide the index, which I'll set as A, B, C, and D. This argument is optional. And then finally, we can provide our column names. I'll just call mine column 1 and column 2, but you can call these whatever you like. So if we look at our output here, we'll see that we now have a two-dimensional tabular data structure with our column names at the top, the row labels going down on the left, and then the associated data in the middle here. Each of these columns here is actually its own Pandas series. So column 1 and column 2 are both different Pandas series. If we ran this without the index and column arguments, then Pandas would automatically create these just as numbers, like you can see here. Like with series, we can also pass a dictionary into our data frame. So let's go ahead and have a look at this. I'm going to go ahead and copy in a dictionary from the notebook file for this lecture, which just contains some different names, ages, and cities. The notebook file for this lecture is just called O2 DataFrames and can be found within the Section 12 Pandas Fundamentals folder. If we go ahead and call the DataFrame function and pass in our dictionary to this, Pandas has automatically set the dictionary keys to be our column names, and then the index has just been automatically generated with numbers ranging between 0 and 11. So this is another quick and easy way of creating data frames. I'll just go ahead and assign this to a variable called df. And df is short for data frame, and this is an abbreviation that you'll see used quite commonly by others. Let's now move on to discussing some of the different attributes, functions, and methods that are available in Pandas. Starting with our attributes, there are 4 main ones to be aware of. And these are the columns, index, shape, and dtype attributes. Columns and index are quite self-explanatory, and we'll just return the columns and indexes in our data frame respectively, like you can see here. Shape will return a tuple containing the number of rows and columns in a data frame, so very similar to the shape attribute that we looked at in NumPy. And then finally, dtypes will return the data type of each column that we have in our data frame. So our name and city columns are object data types, and then age is an int 64. Okay, and next we'll move on to looking at methods. Just like all of the data structures that we've looked at so far, including lists, dictionaries, NumPy arrays, and so on, Pandas data frames also have a variety of methods available on them. We'll of course cover a lot of different functions and methods throughout this section, as well as the rest of the course, But for now, I'd like to introduce some of the most helpful and commonly used methods and functions that you'll come across. Starting with head, this method can be used to view the first rows inside of a data frame, and by default, it'll return the first 5 rows. To call it, we can pass in the name of our data frame, which we just called df, and then a dot to access our methods, and then finally, just the name of our method, which is just called head. If we run this, it'll return the first 5 rows of our data frame, or alternatively, we can pass in a number to specify how many rows we want to return. On the flip side of this, we also have tail, which can be used to return the last rows in a data frame. And again, by default, this will also return the last 5 rows. Next, we've got the describe method, and this can be used to generate descriptive statistics about a data frame, with statistics on the count, mean, standard deviation, minimum value, the different quartiles, and then the maximum value for the columns in our data frames. So this one is very similar to the data analysis toolpack add-on that we looked at for Excel. We'll also see that this has only returned information about our age column, and this is because this method only works for columns with a numeric data type. And then finally, for our methods, we have max and min, which are used to find and return the maximum and minimum values inside of a data frame or series. When used with a series, they will return the maximum or minimum value in that series, but when used with a data frame, they will then return a series containing the maximum or minimum values for each column. With our data frame here, the max method will return a series containing the 3 maximum values for each of our columns, which were Liam, 40, and Seattle. For our age column, this is just the highest number, but for our name and city columns, which had an object data type, the results are arranged in descending alphabetical order, so showing the names and cities starting with the letters furthest along in the alphabet. Minimum will return the opposite of this, so the smallest numbers in our age column, and then the name and city columns will have been ranked in ascending alphabetical order, returning the name of Alice, age of 22, and city of Atlanta. And then for our functions, we'll just have a look at one for now, and this will be the len function, which can be used to return the number of rows in a data frame. We'll be covering plenty more functions as we go throughout the rest of the course, but this is a good one to show you now. If we take our data frame here and pass it into our function, it will return 12, and this is how many rows we had in our data frame, as well as the number of values that we had in our initial dictionary. Okay, and now that we've covered these, let's move on and have a look at how to select or index data from our data frames. Like every other data structure that we've looked at, to index a data frame, we will need to use square bracket notation. It's possible to select either columns or individual rows from our data frame, but we'll start by having a look at how to index columns. To index a column, we start with the name of our data frame, which in this case is just simply df, and then following this, we can specify the name of the column that we want to index. For example, to index or select the name column, we could just put age inside of our square brackets, and then this will have to be in quotes as this column index is a string. It's also important to add that we can index and select multiple columns at once by providing a list of column names inside of our square brackets. To select both the name and age columns, we could pass these into a list here. Now that we've looked at how to index and select columns in our data frames, let's move on to looking at how to change the index labels of our data frame. Currently, our index for this column is just numeric, going from 0 to 11. In order to change this, we can call the set index method on our data frame. So we'll say df and then call the set index method. And then inside of our parentheses, we get to pass in the index labels that we want to use. As we're changing multiple indexes here, we'll need to pass in a list of labels. And then to keep things simple, I'll just pass in some different characters, but you could call these whatever you wanted. I'll just go ahead and fast forward while I add these in. Okay, perfect. So I've now added in index labels for each row in our data frame, going from A up to L. And the reason that I've stopped at L is because L is the 12th letter in the alphabet, and there are 12 rows inside of our data frame, so we need to label 12 rows. If we go ahead and run this, we'll get our expected output below with the letters that we just set for our index labels as opposed to the numbers as they were before. However, something to note here is that if we have a look at our original data frame, we'll see that the index hasn't actually updated, and we still have the same numeric index. The reason for this is that when we use the set index method, Pandas actually returns a new modified data frame without actually changing the original data frame. And the reason it does this is so that if we make a mistake, we don't ruin our original data frame. If we want to apply these changes to our original df data frame, we'll need to specify the in-place argument. And you can see from the documentation here that the description of this is just whether or not to modify the data frame rather than creating a new one. And if we set this to be equal to true, and then look at our data frame again, we'll see that the original df data frame has now been edited. Alternatively, we could also have assigned the result back to our original data frame like this, but either method will work fine, so it really comes down to your personal preference. Okay, and now with our custom index set, we can move on to how to index rows of our data frame. So as I mentioned earlier, it's possible to index both columns and rows inside of our data frame. And there are two ways to index by row in Pandas, and these are the iloc and loc methods. Starting with iloc, this method can be used to index elements by their integer position. And for example, df.iloc0 would return the first row of our data frame. Like with columns, we can also index and select multiple different rows. So here I can just select row 1, 2, 3 and 4, like so. Loc, on the other hand, enables us to index by labels. So here we could say df.loc and then our row index label. And as an example, I'll just use A, which is one of the index labels that we set before. And finally, just to show you, we can also extract multiple rows with loc2, either by passing in specific row labels, like A and B for example, or just by slicing an entire range. Okay, and that's it for our first lecture on data frames inside of Pandas. Just to quickly recap, in this lecture, we've covered what data frames are, and then how to create them with the DataFrame function. Then we moved on and looked at some of the most common and helpful attributes and methods for our data frames, as well as how to set a custom index. And then finally, we looked at how to index and slice different rows and columns in our data frames. And we'll continue looking at data frames in the next lecture as well. Thanks everyone, and I'll see you in the next lecture.